Alright, the next example I have for you starts on the middle of page 4, but I've just copied it onto one page to make it easier to make this video for you. So I have directions that say solve the linear system, that is system of equations, using Gauss Jordan elimination. So I want to work with an augmented matrix so that I don't have those variables cluttering up my view. I'm going to write the coefficients 1, 5, vertical bar representing the equal signs, 4, 2, 3, and 1. So there's my augmented matrix representing the system of equations that I need to solve. The first step is to make the row 1 column 1 entry into a 1, which it already is. Fantastic. So now I need to work on this 2. This 2 needs to become a 0, and I make it into a 0 by taking the opposite of 2, which is negative 2, multiplying it by the row 1 value. So I'm going to squeeze those in here. Negative 2 times 1 is negative 2. Negative 2 times 5 is negative 10. And negative 2 times 4 is negative 8. I'm going to have to combine these two to give me my new row 2 values. This 2 that needs to become a 0 is in the changing row. So I write the changing row first in my abbreviation. So row 2 plus negative 2 times row 1 is my abbreviation. So my new matrix is going to have the first row staying the same because the changing row is written first, and the second row becomes negative 2 plus 2 is 0, negative 10 plus 3 is negative 7, and negative 8 plus 1 is negative 7. And it looks like I might have left a spot to write it in here, but that's fine. So this is the matrix that we're working on here. I have the first column dealt with because I have my leading 1 and the rest of the entries in that column is zeros. So I move down the principal diagonal and I see that this negative 7 is here, but it needs to be a 1. So to work on this row 2 column 2 value, I'm just going to copy this right here. 1, 5, 4, 0, negative 7, negative 7. To change this negative 7 into a 1, I would simply multiply negative 1/7 times row 3. And if you're not sure about that negative 1/7, on the side you could do something like negative 7 times what is equal to 1. Oh, we can't see that. Negative 7 times what is equal to 1. Solve this by dividing both sides by negative 7, and you get the what that you're multiplying by is negative 1/7. So when we perform this row operation here, row 1 does not change. It's not written in the row operation, so it has nothing to do with it. So I copy the row 1 values, and then the row 2 values, 0 times negative 1/7, I'll write this in, times negative 1/7 is 0. Negative 7 times negative 1/7 is 1 in both of those cases. Are we done yet? Well, first column's done. Second value on the principal diagonal is a 1, but this 5 still needs to become a 0. So, what's the row up, I ask you? Well, it's going to be, the opposite of 5 is negative 5, and that needs to be multiplied by the row that has a 1 in the same column, which is row 2. And then once I perform that multiplication, I need to add that product to row 1. So row 1 is the changing row. So when I go to write my next matrix, since row 1 is the changing row, I know that row 2 is going to stay the same, so I could copy those values right in there. But I still need to multiply negative 5 times this entire row. So I'm going to squeeze those values in here. Negative 5 times 1 is, oh, I put that in the wrong place. I apologize. I need to multiply the second row by negative 5. Negative 5 times 0 is 0. Negative 5 times 1 is negative 5. Negative 5 times 1 again is negative 5. So these are the two sets of numbers that I need to add together to perform this row operation. So 1 plus 0 is 1. 5 minus 5 is 0. And 4 minus 5 is negative 1. Now we are done, and we could give the final solution of this system as negative 1, 1.